Okay, so the second learning objective is about explaining and calculating depreciation. So what is depreciation? Okay, what's depreciation? So when UFL first constructed the building, it's called, what is that building called? You guys went to the dealing school business. There's one building, it's called Mark Hall. No, the building on the Lethbridge campus, it's for the dealing school business and nursing. What is that building called? Forgot. Anyone from U of L campus? If you go to dealing school business, that building is shared by dealing school business and the faculty of health nursing, I think. What is that building called? The building is called Mark Hall? No, I forgot. Does anyone know? Okay, so when U of L first constructed that building, suppose the cost is 200 million. Okay, 200 million. So that was done probably 10 years ago. Okay, 10 years ago. So you tell me the condition, today's condition of the building is the same as 10 years ago? No, right? It's getting older and older. So the value of that building, yeah, there might be wear and tear, exactly. So the value of that building should decrease year after year, right? Because eventually, 50 years, 100 years later, that building probably has zero value, right? So you don't go from 100 million to zero one day, right? You don't go from $100 million value to zero values one day, right? So that's through, let's say, 100 years. Right? So if you think that way, you are using the building, right, every year, right, every year when it is useful. Okay. And every year when you use that building, it generates revenue for you, right? Because the student will sit in the classrooms, and the building is one of the reasons why university can realize the tuition revenue, right? So we cannot earn that tuition revenue without the building, the classrooms. But you realize benefit all the time, as long as the building is useful. But the value of the building will go from 100 million and slowly reduced to zero. Right? So how do you reflect this process of this trend, this downward trend of that building's value? So that's why we call it depreciation. Right? Depreciation. So depreciation is a systematic allocation of the cost over the asset's useful life. Okay, suppose the building will be used 100 years. Initially, it's 200 million. At the end of the life, it's $0. So 200 million, if you allocate it into 100 years evenly, so every year is, right, $2 million. So 100 years is 200 million, right? So the idea is you have to recognize the cost of using this building, right? You use the building to generate money, revenue. That revenue does not come without any cost to the building, because the building is decaying. The building is slowly decreasing in the value, right? So that's why you recognize the depreciation, okay? And then you capture the cumulative depreciation. Okay. So every year you recognize, oh, this is how much weight I lose, right? 10 years after, you're going to ask yourself, okay, what is the cumulative weight loss? So you know the year one, you lost 2. Year 2, you lost 3. Year 4, year 5. Every year, you know how much weight you lose. But then you're going to ask your question at the end of the day, right? So far, since the day one, I start losing weight. What is the total amount of weight lost, right? So that account is called cumulative amortization, depreciation. So that account is going to capture all the depreciation expenses over the years. Okay. Okay, so that's called a cumulative depreciation account. Okay, so depreciation is to recognize the wear and tear of the PPE. Okay. And it's just a method to allocate the cost of that PPE into the many years of the useful life. Okay. What are the factors in calculating depreciation? So first, you should know your cost. What is your initial value? Okay, then you should know residual value. What's your end value, right? So at the beginning of the asset, what is that value, initial value? And then you want to know when you retire the asset, you don't use it anymore, how much you can sell it for, that end value, residual value, right? The difference between the initial and the ending, that is your depreciable amount, right? That's how much your value of the asset has dropped, right, over the years. So you use the initial value minus the ending value. That difference represent the amount of the value that should be depreciated, right? And then you should know how many years between the initial value and the end value, right? How many years? That's called the useful life. So in order to properly calculate depreciation, you need at least to know these 3: cost, residual value, and the number of years of useful life. So does anyone have any question so far? Anyone have any question? No? Okay. So the method to calculate depreciation, the common method are straight line, diminishing balance, and units of production. Okay, so let's take a look at this example. A delivery van was bought on January 1st, 2024. The cost, the initial value is 33,000. Estimated residual value, so the end value is 3,000. Useful life, 5 years. All useful life, 100,000 kilometers. Right? So you only know this cost for sure, right? This is the history. This is how much you paid. So you know this for sure. Okay? But this other value is based on estimation. Right? You don't know for sure. But you have to guess a number, right? You won't know until you are in the future. But now we already need to do the calculation. You have to be able to guess a number so that we can roughly do the calculation. Okay, so if you use a straight line amortization, so your cost is 33,000. Your ending value is 3,000. The difference is your 30,000, which is the amount to be depreciated. Okay, that's how much value loss from day one to the end of the day, right? So this is your depreciable amount. Straight line means you allocate the depreciable amount evenly into the years of useful life. So the years of useful life is 5. So 30,000 divided by 5. So every year, your depreciation expenses is $6,000. Does this make sense? So if you understand this straight line method, give me a sum up. 1, 2, 3. What about other students? Do you guys have any question? No question? Okay, so I will move on. Okay. So diminishing balance method. Diminishing balance method. Okay. So under this method, you are going to recognize more depreciation in the early years than the later years. So instead of allocating the depreciation expenses evenly across the years of useful life, diminishing balance means you allocate more depreciation expenses in early years and then less and less. So the amount of depreciation expenses is diminishing. So we call it diminishing balance method. So this type of depreciation method is to reflect that the revenue generating ability for certain asset is like that, diminishing balance. They help you make lots of money in the early years, but their power to earn money gradually decreasing in the later years. So for example, computers, right? Computers. In the early years of using computer, right? That's the time you use it a lot, right? And then it help you generate revenue. But what happened is later on, right? Your computer probably are not used that much because it's too slow, right? The technology is obsolete, right? So the benefit of having a computer is the benefit of having a new computer, right? Not an old computer. So therefore, you match the cost and the benefit. There are more benefit, you're going to have more cost, right? So therefore, you allocate more depreciation, more depreciable amount to the early years, okay, to reflect the fact that you are making more revenue in the early years. So computer equipment would be a very good example, okay? So how to do this calculation? I will show you. Okay, first, you want to know what is your depreciation rate. Okay, what is the depreciation rate? So the way you do it, you go with first use 100% divided by the number of useful life, number of years of useful life. So that's 5 years. So 100 divided by 5, that's your 20%. Okay. And then you're going to apply a multipliers. So sometimes we use double. Okay. Often we use double. So when we use double, it's called a double diminishing balance method. Okay. If the multiplier is double, we call this double diminishing balance method. So you use the straight line rate, which is 20%, times the multiplier 2. So 20% times 2, that is your 40%. And you apply the 40% to your value, right? To your value. So initially the value is 33,000. 33,000 times 40%. So the first year, your depreciation is 13,200. So does this make sense? So if this makes sense, give me a sum up. 1, 2, 3. Okay. Does anyone have any question? How do we get the 2? So they will tell you the multiplier. So in the question, they will say use double diminishing balance. If you see the word double, then that means the multiplier is 2. Okay, what about next year? What about next year? So next year, what is the value to start? So this year is 33,000. And the next year, that number will be lower because of the depreciation, right? So what is the value for next year? What is the value? How much value has decreased on the first year? So first year, what is the amount of the value decrease? Yeah, the amount of value decrease is 13,200. So how much value left? 32,000 minus 13,200. So that's gonna be 19,800, right? So this is called the carrying value. So every time your value is updated, that's called carrying value. So this value times 40%, right? So that will be 7,920. Is that correct? Possibly. Okay. Diminishing balance. Units of production method. Okay, units production method is like, let's say I know that this car has a 100 kilometers useful life. That means I can only drive this car for 100,000 kilometers. What's the unit? The unit is kilometers. The production 100,000. So when I reach this production, when I drive the car for 100,000 kilometers, guess what? That car reached the end of the useful life, and the car will be done, right? So if I drive it for 1 year, I drove that much, then the car will be done in 1 year. So that's called the units of production method. So let's take a look at this question. So first, you use cost. This is your initial value minus your residual value. That's your final value. So you calculate the depreciable amount is $30,000. You know the units of production, the car can be driven for only 100,000 kilometers. So I use the depreciable amount divided by the total units of production. I figured out for each unit, each kilometers, the depreciable cost would be 30 cents. And in the first year, let's say I used 15,000 kilometers, and each is 30 cents. 30 cents times 15,000 kilometers. That's my depreciation expenses, 4,500. So does this make sense? Anyone have any question? No? Okay. So I'm almost done. So when I'm comparing these methods, put them together. Okay. You can see, doesn't matter which method I'm using. So after the number of the years of useful life, my total depreciation expenses are all equal to the depreciable amount, which is the initial value minus final value. This is my depreciable amount. So 33,000 minus 3,000. So my depreciable amount is $30,000. So it doesn't matter which method I'm using. Over the years of useful life, the total are the same. The total depreciation expenses are the same, equal to the depreciable amount. However, if you think about each specific year, if you think about the year of 2025, your depreciation is 6,000 for straight line, but it's much more. It's more 7920 for diminishing. And it's even worse, 9,000 for units of production. So you can see that although if you see the whole picture, right, the total depreciation expenses is equal to the depreciable amount. But for each year, the amount of depreciation is different, right? It changes, it's different. Okay, so I'm going to stop here, and then we can continue on Wednesday. Okay.